Okay, so we are looking at practice exercise 0, a C-sharp warm-up. And I wanted to start that together with you guys and kind of get our legs underneath of us. So I believe that I assigned this to you. Is that accurate? You can see something like this. You want to click on this magic link here. It's going to take you to GitHub Classroom. And I guess I could just do it. I think you've done something like this before, but if you haven't, I assume you'll get a screen like this. And then you'll click accept this assignment. And then when you do that, what it's doing behind the scenes is making a copy of my baseline repo that belongs to you and is shared with me. And it's not shared with anybody else. So now you have this assignment here, and it's generally like, I'm always going to name stuff the name of the class, CIS273 dash practice exercise 2, lab 1, whatever. And then it adds dash your GitHub username. So you have to be logged into GitHub for this to work. Let's see. Yeah, you have to log in. So then once you click on that, I know this is grossly named, but you'll see that this is your repository or repo. So these are the files that I've made as the starting point for this project. For most of the stuff in this class, I'm going to make a repository, make a project, even make a solution for you. In VS Code or Microsoft terms, you can have a solution, which is the big thing, and the solution can have multiple projects. We're going to almost always have 2 projects in our solution because we've got the code that we're doing, which is practice exercise 0, which is actually the problems, the stuff where we're going to do all of our coding. And there's a unit test project that has automated tests that has, for this input, this should be the output. Did you do something similar in programming too? Okay, so it's just that, I don't know if when you did it, like in ZyBooks, you couldn't really see the unit tests if you did it that way. I guess on GitHub you could see it, right? Were they like PyTests? But they'll be here. Ronaldo, your computer? Did y'all have to say who you were? Just log into GitHub was all? You had to change your password? Log into GitHub, Caleb. Like just by just regular GitHub.com and see. Same account. And can you see an old repo and like do stuff with it? You got that too. Anybody else get this repo access error? Okay, hang tight. Maybe try it again in a couple minutes. I'm going to keep kind of moving forward, and I am recording so you can watch it later. Okay, I'm sorry. Okay, so did I have y'all install the GitHub desktop app? It's purple. Looks like this. You got it from another class, so open that up and make sure it's up to date. And then one process for doing this, going back to GitHub, clicking on the blue or green code button, and then click Open with GitHub Desktop. So by doing that, you are cloning the repo, which means you're making a complete copy of your repo and all the version control files associated with your repo. It's not just the code files, it's also the history of all the previous commits that have happened, which won't be very many right now, but you need that whole Git repo. So that, if you do this, I think it'll open a GitHub Desktop if you've got GitHub Desktop installed, and then it'll copy that, it'll download that, technically it's cloning it, to your computer, to some folder on your computer. I think by default it puts it in a GitHub folder under Documents. Yeah. Well, that's not good. So did GitHub Classroom just break? We wrote GitHub Classroom, even if it looked like it worked, it didn't work? Just confirm, we're definitely on FHU. Yes? Are we definitely on FHU? And cloning it doesn't clone it? Okay, so maybe check that, try it again, see if it, in the GitHub Desktop app, there's a open in Visual Studio Code and a show in Finder, or I assume it's show in Explorer on Windows. Okay. Okay, so let GitHub Desktop update. So it should, like in this case, I've got this practice exercise project, practice exercise 0. It has a practice exercise 0 folder inside of it, which is the practice exercise 0 project. There's an SLN file, which is the solution file that defines what projects are in the solution. There's a readme.md, which is just a little file where I've written some notes about what this project is. And then there's the unit test project. So in the GitHub Desktop app, I can click Open in Visual Studio Code, and I get something like this. At this moment, I have the readme.md file open, which is boring, and it's just my kind of title for the project. But this is the right way. If you have a readme.md file in a repo, in the root of the repo, then when you publish your repo here, you'll get a cool readout rendering of the README. So it's kind of a nice convention. Otherwise, there's just nothing here. But we can write lots more documentation or notes to people who are using our code there. Yeah, Caleb. Oh, yes. For your own purposes. Thank you. I forgot. When you have that choice, do you have that? Did you already commit or something? Did it ask you that initially, or did you commit? Did it ask all that question? Did you choose the other answer? Okay. It's kind of basically saying the changes that you make, do you want to be able to share them with the original repository's owner, which would be me? And you never want to do that for this class. In the real world, you might actually be forking a repository to do some improvements to it of open source software, and then you want to send those back to the original owner and say, hey, take a look at this. I made this better. Do you want to pull my stuff in? A pull request is what that would be. And but that's not how we're going to work in our class, because this is your repository for doing your work, and I don't ever want your code in my repository, no offense, because we're doing this in an academic context. Okay, we'll see if we come to that. We can address it later. Okay, so what I'd like you to do is open the code in VS Code, and in this particular assignment, the program CS file under practice exercise 0 is the only file we're going to do anything in. So for our getting started with VS Code, so getting started in C#, I've laid out, I don't know, five or six little functions for us to kind of hack on and get a feel for C#. I think that should be bigger. Is that readable for y'all? Okay. So let's take a look at number one of my favorite questions ever, palindromes. Also, to make sure that we can learn something, we are going to turn Copilot off. Do you have Copilot? I unchecked all files so that it would stop doing its auto-suggest, because the kinds of stuff that we're doing, especially on this project, but generally in this class, are exactly the projects that a million other students have done. And it can read my documentation, my comments here, and write the whole function for you. And that would seem nice, except that it completely removes your ability to learn. And if we do that, what is the point of being in here? Joshua? Okay. Did we install the .NET? Did you install the .NET framework? Have you restarted your computer since then? Try restarting your computer. Okay. You guys know a palindrome? A palindrome is a word that's the same frontwards and backwards. So classically, mom is a palindrome because it's M-O-M or M-O-M. Whereas yo mama is not a palindrome because A-M-M-O-Y is not the same. Yeah? I guess we could almost make it a palindrome. Putting that there. Is that? Yo mama, mama, boy. There we go. So that's a palindrome. Yeah? Hey, one of the coolest ones I've seen is, I think it's a man, a plan, a canal, Panama. I may be off on that. We could, is that right? I thought it was incredible. So what I want to do to make it a little bit more fun is we are going to ignore case. So it doesn't matter if it's uppercase or lowercase. And we're going to ignore spaces. So even if you put spaces between words, they don't count against its palindromeness. Okay? So maybe you've done a problem like this before. I think it's a classic programming 1 or 2 kind of problem. I think it's also a classic basic interview question. Like if you can't do this at a job interview, then you definitely, they're not going to hire you. Right? This is easy. So well, let's have a strategy here. How could we check if a string is a palindrome? I can think of several ways. What do y'all think? Mm-hmm. So we definitely got to do the cleanup first. We would say maybe cleanup space in case. And then in some way, we need to check the forward version of the list of letters against the backward version of the list of letters and see if they're the same. Another approach, which is sort of maybe underneath that, which you can see that I left this in from last time, you could reverse the string and then see if the forward and reversed version of the same string are the same. Does that make sense? I don't know, is that what you were saying? Okay. I think that may be perhaps the most obvious and direct. There's a efficiency issue there. If you had a string that was 1 million things long, you don't really have to reverse all 1 million things to determine if it's a palindrome or not. You can look at the first letter of the string and the last letter of the string, and if they're not the same, then you're done, right? But we don't, I think at this moment, care that much about efficiency, and we're okay to just get it done. Does that make sense? So you can do some stuff just with indices and not actually reverse the whole string. But I thought it might be fun for us to learn how to write a function and call a function. And that's what this private static string reverse means. So it takes in the original string, and it's going to return the reverse of the string. How could we reverse a string? Okay, so I like what you got going there. You guys really love lists. Lists are cool. And I think we're going to not use a list for this. I wonder if we could do it with just a string. If I had the string reverse that was initially blank, what if I said that the reverse plus equals the original at like its last character? Looks like, I believe, we can index a string and strip out characters. You with me? So we're kind of treating a string as if it were a list. I guess you're used to slicing in Python, right? It's kind of like that. C# doesn't have that cool feature of Python where you say, was it like -1, and it goes through it backwards? So I wonder if we were to create a for loop and we say for int I equals, and I want this to be the last index. And I'm not sure what that is yet, but I'm going to figure it out. So I'm just putting in this last index as a placeholder. And I want to make sure that I is greater than 0. And I'm going to say I minus minus. Now, this is my instinct to do this, is to start at the last index of the string and work backwards. And as I go backwards through that, I'm going to do this thing that I wrote, which is I'm going to add on to the reverse string the original string at I. So you see that I want this to be, what's the last index of the original string? I mean, it depends on how long this is, right? Boom, yes. So we want to get the length of the string, and it is capital L length. Excellent instincts. And I believe no. So what we're going to learn is this, in C#, there's something called a property. And a property, properties have capital letters by convention, is like a method, like it's like a function, but it doesn't have parentheses. We access it as if it were just a plain old piece of data. My instinct is that I'm off by 1 here. What's the length? What's the length of MOM? 3. And what are the indices? 0, 1, and 2. I really want to start here with index 2. So I need to say length minus 1 to move it back 1. And then if I've done this right, I can just return the reverse. Okay. So I'm breaking some stuff here in a way that's not that good, but this is an okay first pass way of doing this, in my opinion. You follow me? So I'm kind of building this string in reverse, 1 character at a time, going backwards through the original string. So this is going to be, if the length is 3, then the first time through the loop, it'll be 2. And then it'll do minus minus, and then it'll be 1. And then it'll be 0. I actually need to hit this at 0. So this needs to be greater than or equal to 0 so that I actually go through it when it's 0, because I need to do it 3 times. Okay. Now, I don't trust that I did this right, so I would like to test it. So I'm going to come up to my main method. See this static void main? And I'm going to call reverse with some string. What do we want to do? Now I'm lost. We got to get a really good word to test it with. So now look what's happening here. If I call the function reverse, if I'm hovering over, you see it. It returns a string. I'm not doing anything with that string, so this isn't going to print anything out, and I haven't saved it to a variable. So my instinct would be here to console.writeLine the result of calling reverse. Yeah? So now I want to run this. So I'm going to look at my console down here at the bottom, and I'm going to run .NET run, and it's going to give me an error. This error is saying, I don't know what project to run because you're in this folder. You see I'm in practice exercise 0, the outer folder. That's this folder. You know, PWD will print the working directory. So you see that I'm in the outer practice exercise folder. So I think I can either CD change directory into practice exercise 0, or what makes sense to me is to say .NET run -- project. You can specify which project you want to run. So I'm going to say -- project space practice exercise 0. You got to spell it right. I'm sorry. So in this case, I'm telling it which project to run because there's 2 projects in this folder. There's a unit test project, the practice exercise 0. Does this command make sense? Let's see if it works. Looks like it's working. Look at that. Those are like backwards letters. So again, to run this project from the folder that has 2 projects in it, you can say .NET run space -- project. So you're giving it the project flag, and then the name of the project that you want to build and run. In this case, practice exercise 0. Yeah? Okay, so to me this says this reverse is, I think, working. There are improvements we could make, but I'm okay with this. So we've taken some string as input, and then we've made a copy that's in reverse. And we've made the copy by going backwards through the string using this style for loop where we say starting position, which is original length -1, continuation condition, which is when do we stay in the loop. We continue to loop as long as I is greater than or equal to 0. If that's true, then keep doing it. And then at the end of each loop, we decrement, decrease by 1, this I, this index. And then all we've got to do in the loop is just extract the I character out of the original. So that's getting it from the back to the front of that string. And we're adding it on to reverse, concatenating. Yeah. We could do that. I like to have my functions just do one thing instead of trying to do everything. And I believe that there may actually be a way for us to use some built-in methods to remove the spaces and change the case. So I wanted to show you that. But that's a good idea since you're already going through it. If you want to do it most optimally, maybe you could just do it on one pass. Notice this though. I'm going to go back up to my is palindrome function, which you'll notice the data type is what? It's Boolean. Yeah. I would like to say string clean is equal to, let's see, now this is called S, okay, S dot. And I think there is a to lower function. When you say dot, you can see all of the methods that are defined for this object. So I would like to say to lower. If you see when I hover over to lower, it says this returns a copy of this string converted to lowercase. So it doesn't lowercase this string, it doesn't change the S, it returns a copy that is changed. And you'll see that most methods do that. I'm going to say to lower. Now this is a function. So I've got to put parentheses. So I'm going to call to lower. So this should take what? Yo mama and convert that to yo mama. Yeah? Does that make sense? So instead of us manually doing that for every character in the array, which we could do, or every character in the string, let's just call it to lower. Okay. We also have to get rid of the spaces. If we were going to do this manually, like we did with reverse, how would we do that? Strip it? Strip? Have you all used strip before? Was that a Python thing? Yeah. I don't have a strip function. I was imagining, or if we did it letter by letter, let's imagine. I'm going to put underscores where there's letters, where there's spaces, so you can see it really easily. We could make a copy of this, and as we're making the copy, we only copy over the letter if it's not a space. So we see this and we say, do we copy that space? No. So our this is our new string down here. It's nothing. See that? We get to Y, we do copy over the Y. O, yeah, space, we don't copy spaces over. But when we get to the M, we do. If I were going to manually do it, I would do it that way. But if I were going to use a built-in method, which there's so many built-in methods, that's what I wanted to expose you to, that for many string manipulation operations, C#'s got your back. You should probably just use theirs. I think there's a replace. And I think replace is what we want to use. So let's look at replace here. Let me, sorry, it's hard to see this pop up. Let me see if it, okay, that's what I wanted to see. So you can replace an old character with a new character. See that? Returns a new string in which all occurrences of a specified Unicode character, in this instance, are replaced with another specified Unicode character. So again, it's following this pattern. You can see it. Oh, I can't do both. It returns a string. That's what this means. This returns a string. You call it on a string. It's a object. It's a method on the string object, string class, that Microsoft gives us, and we pass in an old character and a new character. So when I open the parentheses here, do you notice it shows me the same kind of documentation? I feel like reading this documentation is important. You can stay in the VS Code and learn most of an API when it's commented like this. You can see I can actually go down, and this method replace is overloaded, where overloaded means there are different versions of the method that have the same name, but they take different types of objects or different numbers of parameters. So the first one replaces one character with another character. But they also give us a version where you replace an old string with another string. So if you wanted to replace multiple characters at a time as a string, you could easily do that. It looks like there's also one where you pass in a string comparison type, which is kind of fancy to say if we're going to do some kind of fancy comparison to see if strings are the same. And there's an even greater, more complicated one where we also have an ignore case and a culture parameter to define the culture. Okay, the first one is what I want. I would like to replace the old character, which is space. Hang on. This actually works either way. If it's a character, it should be in single quotes. I want to replace the space character with what? Nothing. Okay, ChatGPT is helping me out here. This is gross. So I'm going to, this isn't the way to put in an empty literal character, and instead I'm going to treat this as a string. We've got that string overload, so when I find the string space, I'm going to replace it with the empty string. That's a lot of quotes. You follow me here? That's a space string. This is the empty string. This is going to help us avoid that weird empty character issue. All spaces get replaced with nothing, which makes them disappear. So this is essentially doing what y'all called strip in Python. Okay, notice again though, I'm not quite done here at all. When I do this replace, did I change what was in clean? No. So this is something to keep in mind. I see us often make this mistake where it does look like you did this operation, and you did it, and you returned a copy of this that was no space, but you didn't save it anywhere. So we could say string no space, no spaces, or maybe even it's clean, no spaces, because it is both now. It's this. Yeah. And now that I've cleaned it and removed the spaces, now I can do my check, which we made this simple check, which is to say, reverse it and see if the strings are now character by character the same. So I'd like to say string reversed is equal to reverse clean no spaces. So now I've made a copy of it. So if it was this yo mama string, we've just, in this line, we lowercased everything, and in this one, we took out all the spaces. And now, in this line, we've reversed it. So that was our input, yo mama, and now we would have a A-M-A-M-O-Y. Yeah? All right, our last thing is what? Hmm? S is our original string, right? So if S equals the reversed, all right, and now the thing that we like to test is, are those two strings the same character by character? And I think that equals will actually test that. More on this later when we talk about reference types and value types, but also I believe this is how equality equals is defined for strings. Okay, so let's see if this works by testing it, because we got to test it to know if something works. So now I would like to call is palindrome with true bass as the string. Should be false. So I'm going to come down here and execute the .NET run -- project. You can press up to get to previous commands, up. So you have to type it all again. And false. Well, that's not a great test because maybe we just got lucky. So let's put something in that is a palindrome. Like what? Race car. Here, let's try it one at a time, huh? So that should be true, all in lowercase. Hey, that's true. Sweet. Now let's put a space in there and do it again. It should still be true. Oh, it's false? What did we do wrong? Mmm. Mmm. So what should we test? We should test clean no spaces to reverse. Because what we were then doing was testing it against the original string that might have had spaces and cases. Good call. Okay, so I changed this line so that the comparison is between clean no spaces and reversed. And that is true. Let's test it more. Let's put in some crazy capitalization. Race car. You know what? I'm feeling like, oh, not the period. We're just going to put some extra spaces in there too. Yeah? Not the period. That should also be true. Yeah? Hey, it's true. And if I put a period, that should make it false. Good? Okay. So what I'd like you to see here is kind of a way of interacting with our IDE and a way of manually testing your code, which I think is a good idea so that you can see, like actually all within here, I should have done this. At any of these points, I could have said console.writeLine and printed out any of these things to see what's happening. Also learn how to debug this thing. More on that next time. Okay. If we want to actually evaluate this the way that the grader is going to grade it, then we want to run our unit tests. And the way to run the unit test, this, is on the command line, just say .NET test. It's a complex command. You feeling this? And it does take a minute. And it shows us the summary here at the bottom. There were 14 total tests. We failed 9, but we succeeded in 5. So if you scroll up here, I see there's a bunch of junk here, but we shouldn't be surprised that we failed some unit tests because you've only done like one of the 4 problems. All right, so there's, hang on. This guy that reverses an integer, the integer could be positive or negative, and I want to retain the sign. So if you reverse 532, you get 235 as an integer, not a string, an integer. If you reverse negative 6387, you get negative 7836. You with me? Yeah. I don't like that space there. My bad. Space should be there. My bad. Last time that we did this, I coded this in 2 different ways. You don't have to do it in 2 different ways. Can you think of what would your approach be to this problem? Convert it to a string. I think that's a very solid approach. It is a lot easier. I think it's more obvious how to reverse a string than to reverse integer. Ignore the sign. So just figure out if there's a sign or not. If there is a sign, you might actually, if there's a negative, then maybe take it off. Reverse it. If there was a negative, remember it, add it back on after you've done the reverse. And we just saw how to reverse a string. So you could actually reuse that little method. So that, but then there's one other thing you got to do. Does this method return a string? No. See, but you're going to have a string if you converted it to a string and then reverse the string. How do you make it back into? We had that int.parse. Remember int.parse, which will convert a string back into its integer representation. So you're going to have to do that data type. And we'll show that because strings are so important because it's how anything can get printed out to the console. Any item has a toString. Any variable has a toString. So if you say i.toString, it'll convert it to a string. So that'll be easy. And in fact, because toString is so common, let's see. Nope. Okay. If you wanted to do it this way, you do have to explicitly take it to string. Does that make sense? I just put this, I converted I to a string to pass it into the function that only takes a string. That string would reverse it. That function would reverse it, the reverse function that we just wrote, and then we get it back here in the reverse. You might want to remove the negative sign first, though, if you're going to do it this way. Otherwise, the negative sign will be at the end, right? And that's gross. So I would just take it off. Which you could, how do you take off a negative sign as a number? You got. So I'm sorry, no, you could do that. That's fine. I guess that's fine. You're thinking like a mathematician. So I was just going to multiply by -1. But yeah, I was going to put it in an if statement. So maybe yours is cleaner. So let's try to do that. So if I had a int abs, that's what I got. One of them. All the math functions are in the math library, which is included by default. Like you don't have to import it. So you just say math dot, and you can get to all of the mathy things you ever wanted to get to. There are constants in here. So capital P, capital I, math.pi is how you can get to pi. You can also do logs and powers and probably stuff you don't care about, like hyperbolic sine. I mean, who even needs that? Dr. Collins. But abs is right there. So math.abs, and we could just pass in I. Was I the name of our integer? Yeah. So this would essentially then take the number off. Now what you got to remember is here at the end, sorry, I don't want to pass in I.toString. Now I'm going to pass in abs.toString. Yeah? So this has reversed it. And then I would need to say if I was negative, how could you say that? Yeah, if I was less than 0, then I probably need to do something like add back the negative sign. And then I'll probably need to convert result to int. You with me? We talked about we got to convert it back to an integer. So for a lot of these kinds of functions that we're writing, I would be inclined to have something like result, which is the thing that you're working to compute, and then you would return the result at the end. Sorry, it's the wrong data type, so that doesn't work. There is another way of doing this that only uses arithmetic operations, which is very clever, and I don't really need y'all to do it, but it's clever, and I think it's a cool thing to see. So if you had the number 475, okay, if that was our number, what would happen if we divided that number by 10? If we took 475 and divided by 10, that would definitely be 47. And what would the remainder be? It would be 5. So 475 divided by 10 is 47, and 475 mod 10 is 5. You with me so far? Okay. So let's have a result that we're accumulating. I'm going to begin with the result equaling 1. And when I get my 5 out, I'm going to multiply by 5. I think I'm doing that wrong. No. I'm going to start it at, I'm going to start it at 0, and I'm going to add 5, which is 5. Okay. So I've got 5 at this point. I take this guy, $47, and I'm going to repeat it. So I'm going to say 47 divided by 10 is equal to, can you do this one? Remember this? Math? That's 4. There's no points. But 47 mod 10 is 7. This is the magic that I skipped. I'm going to take 5 times 10 plus that. 5 times 10 is 50 plus 7. You see what's happening here? Let's do it again. So now we've done this. 4 divided 10 is equal to 0. 4 mod 10. 4 mod 10 is 4. So multiply this by 10. Add the remainder. So there's a little cleverness. I don't know if anybody would ever put such a thing on like a technical interview, but you see you're just repeatedly dividing by 10 to strip out one digit at a time. You're dividing and modding. So you can do that if you have to. I don't really, the unit tests don't test reverse int2. That was just bonus because I thought that cleverness would bless your life. Okay, we got 2 more. Nope, 3 more. Ooh. Okay, is unique. I would like you to write a function that will accept a string of alphabetic characters and will determine if all the characters are unique. That is, there's no duplicates. Does that make sense? No duplicate characters. So if we had like Ethan's name, is there more than one E? Is there more than one T? No. So Ethan is unique. Cecily, how do you spell your name? This is Cecily's name. Is this a unique set of characters? This is not unique. So if we put these characters into that function, it should return false because there was a duplicate, at least one. It doesn't matter, like really, as soon as you found one duplicate, you know that's not unique. For Ethan's name, we actually have to check every character, right? We don't know until we check them to know that none of them were duplicate. Have you seen a problem like this before? And do you have an idea of how to solve it? Okay, this is one way to solve it that I would say is the naive way, but naive is fine. Like you should at least know this way. Okay, let's do Ethan first because Cecily is too easy. We immediately get the right answer. Okay, so for Ethan, one way we could approach this is to say, okay, this is our letter, E. Yeah? All right, so for E, is E the same as T? Nope. Is E the same as H? No. Is E the same as A? No. Is E the same as N? Okay, so we checked E versus everything else. E is unique. Now, we move forward and check T. And in this case, do we need to check T versus E? No, because we already did it. So now we can say is T the same as H? No, no, no. All right, and then we move forward to the H. To the H, HA, HN, nope. And then here, and then A and N. And I think that's all we have to do there. Because you would never compare the same letter to itself because it's obviously the same. We just have to check everything else. So this is checking everything versus everything else, but in a way that is, what would you say? It's like permutation combination thing, like the order doesn't matter. If E is the same as N, then N is the same as E. Or if this character is the same as this character, then it's the same in reverse. So whenever you see a problem like this, where you've got like one thing that's moving through the list, and then for every one of those things, you have to move through almost every other thing on the list, I want you to think of this structure, okay? Or maybe you already know it. There's a clear looping structure that applies in this scenario. Do you know what that is? For, I like for, and specifically, it could be for each. Although I think I like I's and J's. It's a nested for loop. So a for within a for. So our outer for loop, the outer for loop was this black arrow that moves one letter at a time. The inner for loop is saying, based on where the black arrow is, check all the purple connections between the current value and all the others. So does that make sense? I think like once you see this pattern, it's a common useful pattern to know. So I'm going to say for int I equals 0, I is less than, probably the length of the string is how many things I have to do it, and then I'm going to say I plus plus. So So this is going to go through if I get string at I, why's this mad at me? Oh, oh, so this should be a char. Okay. I don't understand that error. It doesn't like me just having a character sitting out here. That's not okay. I just wanted to show you, this is how I would get each element. So S at I is the I character in this string. Okay. And then I'm saying I need to go through all the other combinations of that letter with the other letters. Yeah? So the pattern that I want you to see is, and this is like we just traditionally use I and J as index characters. You could call them something else. But I'm going to say int J is equal to 0, and then J is less than the length of the string, and J plus plus. And essentially what I want to do here is to say if S at I is equal to S at J something. Does this make sense? So this is like the structure of how we would, then we've got two different iterations going, and the one improvement you want to make is J does not start at 0. Remember here, if I is pointing at E in Ethan, then where do I point the next one? T, which is one more than it. So here, this is always going to be I plus 1. So go to the next one. So you only have to check from the next one to the end of the J's. If S at I, so S at I would be E, and S at J would be T. If they're equal to each other, which would mean we have some word that was like E. As soon as we see that there's two E's, they're the same, then I can return false, right? I found two that are the same, so it's definitely not unique. If I go through all of these loops, then I return true, because that means I never found one that was the same, so it must be true. All right, thanks for giving me the extra minute. I'll see you guys soon.